Some series to integral calculus. Some series to integral calculus in which we are pursuing the discussion. Amazing, mind-blowing, thrilling. There is nothing beyond integration calculus in calculus. Differential equation, derivative, all are facets of integral calculus only. Integral calculus is the root of calculus. Like addition is addition is considered as root of mathematics. Subtraction comes from addition only. There is nothing called negative in mathematics. Everything is positive only. If negative is there, if 2 minus 2 is there, then it is equal to 2 plus and in bracket minus 2. 2 plus in bracket minus 2 means minus means opposite direction. If I get something and I say it is plus, then direction becomes opposite, then I say it is minus. So if I get 2 mango, then I get 2 mango, 2 plus 2. Then I get a mango, but direction is opposite, plus minus 2, because direction is opposite. So if we say that vector is an entity that brings direction into the mathematics, then vector is integral part of mathematics only. Mathematics starts with direction only. So addition, mathematics base is addition, and whatever we see in mathematics is a spectrum of addition only. If I talk about integral calculus, then everything comes in the spectrum of integral calculus only. Everything. Differential equation, first order, second order, nth order, and then a linear differential equation, non-linear, homogeneous, inhomogeneous, semi-linear, quasi-linear, whatsoever. Everything is a spectra of integral calculus. See how nicely, how easily we are calculating the summation series. How quickly, how nicely we are able to calculate the summation series. Anyway, what is the summation? We have tackled negative and positive also in the summation series. People can see Fibonacci series. All the series in, I believe, 3 or 4 we have made in the Fibonacci series, and we would be the first one to calculate the summation of Fibonacci series. Generally, no one has calculated summation of Fibonacci series. What series we can try now? Grandi series. Has anyone heard about Grandi series? There is a Ramanujan series also. There is a geometric series also. There are many series, innumerable series. But problem is that all series are being solved by different methodology. If there is 100 series that can appear in examination, then students has to learn 100 way to calculate the summation of the series. That is extremely difficult. Through integral calculus, there is only one way to solve. There is only one way to solve all the summation series. What is Grandi series? This is in question to anyone. What is Grandi series? What is 1 minus 1? Any would jump 0. What is 1 minus 1? Sorry. There is a series called 1 minus 1, 1 minus 1. How much it is? Pairwise it is 0. Anyone would jump, it is 0. It is 0. Okay. What is 1 minus 1? 1 minus 1, 1. 1. Answer is 1. What are you trying to say? I am trying to say, let's make a slot. Let's take a bucket. Okay. Let's take a bucket. Bucket number 1, bucket number 2, bucket number 3, bucket number 4, bucket number 5, and so on. In bucket number 1, I am placing number 1. In bucket number 2, I am placing number minus 1. In bucket number 3, I am placing number 1 again. In bucket number 4, I am placing minus 1. In bucket number 5, I am placing a number 1. What do you mean? In all the odd number bucket, this is called indexing also. In the indexes, Where bucket number is odd, I am placing positive number, positive 1. When bucket number is even, then I am placing minus 1. 1 minus 1, 1 minus 1, 1. Now I'm asking if it goes for infinite, this is Grandi series. If it goes for infinite, then what is the summation? Now people would say it depends. Which one is your last slot? Last bucket has index as odd or even? Anyone would ask. Then Mr. Grandi he is saying infinite. I don't know. The last bucket is even or odd. I don't know. But still can I find the summation? Okay. Someone would say if your infinite, if it is going for infinite and last bucket is odd, then answer is 1 because pairwise it will be 0 and last odd bucket number will be 1 and answer is 1. If last bucket is even number, if last bucket number is even number, then it is 0 because pairwise it is 0 and it is 0. Mr. Grandi is saying that no, or Sir Grandi is saying that no, it is going to infinite and tell me the summation. Okay, in that manner, he tried another way. What is the way he tried? Consider the summation in S. S equal to 1 minus 1 plus 1 minus 1 plus 1 minus 1 and so on. Makes sense. Now write it again 1 minus s. If this is s, then write it 1 minus s. That will be equal to 1 minus 1 plus 1 minus 1 and again to infinity. First term is 1 minus 1. That will be 0. And then it will start from 1 minus 1, 1 minus 1. Same story will start again. So 1 minus so left hand side at the beginning is capital S equal to 1 minus 1 plus 1 minus 1 like so. Then down I am writing another line. 1 minus capital S equal to 1 minus S. S is 1 minus 1 plus 1 like so. If I settle it down, it will become again 1 minus 1 plus 1. So both are same. S equal to 1 minus S. 2S equal to 1. S equal to 1 by 2. This is what Sir Grandi says. The summation is 1 by 2. If you take it infinite, then summation is 1 by 2. The question is arising. When we are solving everything through integral calculus, can we prove it that through integral calculus it is really 1 by 2? No one would have done in the past. I bet on it. Can someone really prove through integral calculus that indeed it is 1 by 2? Sir Grandi, whatever he has said, 1 by 2, it can be proved. I won't say whatever he has said it is true or false because they are very big people. But still, we can prove through other way also that indeed it is 1 by 2. Okay, can we prove that it is 0 if last bucket or slot is even and it is 1 when the last bucket or slot is odd. Okay, these are the things that we will try through integral calculus way. Okay, now through integral calculus way, if I have a summation like this, first of all, we showed two ways. One is through if it ends in even. If it ends in even, then it is 0. When slot number ends in odd, then it is 1. Can we consider 1 plus 0 by 2, average and 1 by 2? No. No one would trust on this methodology. This is the wrong way. But someone will say, anyway, I got the hint, or something like that. Let's try with successive approximation, the technique that we have invented. And through that, we will try to calculate the Grandi series, Sir Grandi series. Okay, now we have 1 minus 1 plus 1 minus 1 up to n number. Consider it is up to n number. Then I have n number of numbers and first is 1, next is minus 1, 1, minus 1. Let's take x-axis. Okay, let's take x-axis. This is x-axis. When this is x-axis, then this is y-axis. If this is y-axis, then this is x-axis. If this is x-axis, then this is x equal to 0, x equal to 1, x equal to 2, x equal to 3, x equal to 4, and so on. When x equal to 1, when x equal to 1, I have a vertical called function over x or y. When x equal to 1, I have a function over x called y. So that is 1. When x equal to 2, it is minus 1. When x equal to 3, it is 1 again. When x equal to 4, the fx or y is minus 1. And it goes like this. Now, to solve it, let's segregate the positive number and negative number. All positive number, that is the y, are at x equal to odd number. X equal to 1, x equal to 3, x equal to 5, x equal to 7. Because calculus is a terminology, is a technology which works on algebra, number one. Number two, it needs independent and dependent component. There must be one dependent component and there must be one independent component. If it is 3D, then XY plane will become independent component. You can break later. But it will be Z will be function over XY will be dependent component and XY plane will be independent component. There must be one independent component and one dependent component. Okay. Now our independent component is x-axis. Now we have segregated our problem into two parts. One is odd x value, that is odd, and x value, that is even. For x value odd, we have x as 1, 3, 5, 7, something like that. And function over x is 1, 1, 1, 1, 1. What are you trying to say? I'm trying to say summation. Summation x equal to 1 to n. Summation x equal to 1 to n fx. This is the summation for odd number. Summation x equal to 1 to n fx, where x will jump 1, 1, means x equal to 1, then 3, then 5, then 7, and then it will go up to n. Not there are n number of terms, it will go up to n. There are probably n by 2 terms whatsoever, but it will go up to n. So fx plus fx plus fx plus fx plus fx, where x is 1, 3, 5, 7, n. Okay, this is what we have to add. Now with successive approximation, we say I take x as only odd number. When x equal to 1, then we have 1. X equal to 3, then we have 1. X equal to 5, then we have 1. X equal to 7, then we have 1, and so on. If I touch all the top point of 1, 1, 1, it will draw a line. It will draw a straight line, flat line. This is a flat line. This up. This is a flat line. This is a flat line of height 1. And this is fx, function over x. So I can rewrite it summation x equal to 1 to n function over x, where function over x is constant 1. So it will become 1 plus 1 plus 1 plus 1 up to the where fx equal to 1, fx equal to 3, sorry, x equal to 1, 3, 5, 7 till x equal to n. How many terms are there? I don't know how many terms are there. But x starts from 1, 3, 5, 7 up to n. That I know. Okay. Now consider there is another function called gx and it is a continuous function. Gx is a continuous function, whereas fx, that is a flat line here, is a discrete function or also called point mass function. Discrete function means it is not continuous the way it is looking. It is actually combination of some points. X equal to 1, then one point is there. X equal to 3, then one point is there. Function over x at x equal to 5, 1 point. If I connect all the points, it draw a line. But it is a discrete function because it does not have any value continuous manner. Only at x equal to 1, 3, 5, so. But there is a continuous function called gx. To discrete function, we cannot calculate the integral calculus. We need a continuous function. Okay, if it is a continuous function gx, then let's take the vertical that we have seen. At x equal to 1, I have a vertical. At x equal to 3, I have a vertical. At x equal to 5, I have a vertical. At x equal to 7, I have a vertical, and so on. If that is the case, then between x equal to 1 and 3, these are the two samples. If I draw a if I draw an area like this, if I draw x equal to 1 and 3, I take an area strip and it goes and hit gx, then this area is limit x equal to 1 to 3 gx dx. Consider this area from x equal to 1 to 3. This area is exactly same as what we have fx, that is a flat line, at x equal to 1. What are you trying to do? We are trying to do at x equal to 1. At x equal to 1, I have a vertical of 1. This 1 vertical of 1 will be same as x equal to 1 to x equal to 3 area strip between in gx. Then at vertical at x equal to 3, this in fx will be same as whatever area I see from 3 to 5. Vertical at x equal to n will be same as area from x equal to n plus 2 going to hit gx. You mean there are equal number of sub area I have vertical? Yeah, certainly. This is what I'm saying. Fx plus fx plus fx plus fx. Last term is when x equal to n, same as limit x equal to 1 to 3 gx dx plus 3 to 5 gx dx plus 5 to 7 gx dx plus n to n plus 2 gx dx. Now we have equal number of sub area that we have fx plus fx plus fx plus fx, where x is x equal to 1, 3, 5, 7 up to n. For fx at x equal to 1 is same as 1 to 3 gx dx, limit x equal to 1 to 3 gx dx. Fx at x equal to 3 is same as limit x equal to 3 to 5 gx dx. Right hand side area of the vertical right hand side area in the gx is same as left side fx. You mean if I take any x equal to x, if I take any x equal to x, if I take any x equal to x, then I have fx. Yeah, this fx will be same as right hand side x to x plus 2 area in gx. Yeah, exact. Means fx equal to limit x to x plus 2 gx dx. I don't know what is gx. What is your fx? Fx is 1. Okay, 1 means what 1? 1. 1 is a constant. Fx is 1. Okay, if fx is 1, then we have fx at x equal to x is 1 equal to limit x equal to 1 to, sorry, x equal to x plus 2 gx dx. If that is the case, then what is gx? I have to find gx. If I find gx, then I have found the equation. I have found the equation of a, a continuous line. If I find the equation of continuous line, then we can achieve the full summation from x equal to 1 to x equal to n plus 2. Then I can get the complete summation. We'll try. Okay. Now fx equal to gx dx, dx equal to dfxy by dx. We will try now fx equal to gx dx. This means gx equal to dfxy by dx. Dx equal to dfxy by dx. If that is the case, fx is 1, that it comes as 0. Gx will be 0. We'll start with 0. Now 0 dx, x equal to x plus 2. Dx dx, x equal to x plus 2. Okay, in that manner 0 dx is 0, 0, 0, 0. Now we have this side integration as 0 and this side we have 1. Fx is 1 and we are getting 0. Successive approximation. So this will not work. We have to take gx as different value. Whatever we had taken, we have to add by 1, then it will become 1. So we had taken 0, then we will add by 1. So we'll try with 1 now. 1 dx, x to x plus 2. It will come as x to x plus 2. It will come at 2. 2 and this side 1 means then I have to make it half. So we'll try gx as 1 by 2. We will try gx as 1 by 2. 1 by 2 dx. 1 by 2 dx. We'll start again. 1 by 2 I can keep outside and it will become 2. X to x plus 2 it will become 2. Then it will become 1. So same. Now we have gx as 1 by 2 and we'll start. So we have found a continuous function gx that is 1 by 2 and it works. Its area underneath it is same as the summation of all the vertical in fx that we learned. We try now 1 by 2, 1 by 2 dx, then it will come as, now we will try the net integration. Okay, so we will try the net integration. We'll try the net integration here from the x equal to 1 to n plus 2 to n plus 2. Okay, then we'll try x equal to 1 to n plus 2. 1 by 2 dx. It will become 1 by 2 outside, it will become n plus 2 minus 1, n plus 1. It will become n plus 1 by 2. So addition of all odd number up till n, where n is odd number, is n plus 1 by 2. Let's try for the even number, even slots. X equal to 2, 4, something like that. When x equal to 2, then it is minus 1. X equal to 4, then it is minus 1. Leave the minus right now. Just calculate the summation of all the plus. Then it is again 1, 1, 1. So fx equal to 1. And then again we have gap of 2. X equal to 2, 4, 6. Then x gap is 2. So we'll try x to x plus 2 gx dx. Here gx may be different. Fx equal to 1. In that manner, dx will come as same thing. So dx will come again 1 by 2. 1 by 2 for even number slots. Makes sense? Okay, if it comes again 1 by 2, then we will try again. What will be the final summation for the integration for the even number? It will start from 2. And if I take n as even number, if I take n as even number, it will go n plus 2. So limit x equal to 2 to n plus 2. Limit x equal to 2 to n plus 2. 1 by 2 dx. 1 by 2 dx. Okay, in that manner it will become 1 by 2 and then 2 to n plus 2. N plus 2 minus 2. N by 2. Now we know what is the final Grandi series. Final Grandi series is n plus 1 by 2 minus n by 2, where n is even number and here n is odd number. Both are different. Okay, if I take odd number as the maximum number, then n by 2, the last we have calculated there, n I have to replace with n minus 1 because it will be less than the odd number. In that manner, it becomes n plus 1 by 2 minus n minus 1 by 2. Then it will become 2 by 2 and 1. That is perfect. If odd number is more, odd slot is more than even slot, then answer is 1. Consider that odd slot is less and even slot is more. Last term is minus 1. In that manner, then I have to subtract n. I have to place n at n minus 1 in the odd number calculation. It was n plus 1, it will become n minus 1 plus 1, n by 2. N by 2 minus n by 2, 0. Perfect. If odd number is the last, then it is 0. Answer is neither 1 nor 0 as per Sir Grandi. Then what is the solution? N plus 1 by 2 where n is odd number minus n by 2 where n is even number. This is what we calculated. If it goes till infinity, then n will be same. Perfect. If series goes till infinity, then we don't have any distinction between n is odd or n is even. This is what Sir Grandi is saying. So we can settle it down. N plus 1 by 2 minus n by 2. That will come as 1 by 2. If it is going till infinity, then even n and odd number are indistinct. We cannot distinguish. It is n and both will behave as same. Then it is n plus 1 by 2 minus n by 2. It will come as 1 by 2. This is the perfect proof through integral calculus, and I bet if someone has done it, This is the exact proof of Grandi series, not one S and one minus S and those. This is the exact proof of Grandi series. We will work more on it and we will take left hand side area and central area also. There we will see actually it comes 1 by 2 from that side also or not. No one has done it. We are first one to do it. Okay, mine supporting us plus 91 is the India country code 9483160610 is the telephone number. Plus 91 is the India country code 9483160610 is the telephone number.